Well, good afternoon, everyone. I hope you all are having a great day today. Certainly good to be here on a Friday. We do have two groups presenting today. So the first group is Jarek and Robert. So they're both going to present about Chapter 9. And then we have a second group who will be presenting about Chapter 9. That group is Beckett and Arena. So they'll be presenting via Teams. I just want to remind everyone, since we have one group presenting face-to-face and another group presenting via Teams, if you would please, if you're going to be participating in the extra credit, if you'll participate in the one that's however you're attending. So if you're attending face-to-face, we'd certainly be happy to have you participate face-to-face for 8 points of extra credit. If you're participating via Teams, there will be the second presentation there that you'll be able to participate in and earn extra credit that way. So it'll be 8 points as well. Just a reminder to everyone, to earn extra credit, you do have to raise your hand, or not raise your hand, but speak. So, if you're joining via Teams, that means unmute yourself and speak. I'll make sure to write your name down. Apart from that, any questions before we hand it over to our presenters? All right, guys. Well, we're going to go ahead and hear Robert and Jarek's presentation.
Okay. For the clicker, which way do I push? Okay. Okay.
All right. Good afternoon, everyone. My name is Jarek DeRose,
I'm Robert.
and today we're going to be talking about Chapter 9, which is the relational models and relational algebra. Starting off with, what are relational models? As we discussed in class, relational models are kind of a relationship between rows and columns where it's like for every row there's an equal number of columns. They were heavily created by Kai, which he had also came up with a set amount of rules that kind of help define like what is a true relational model. It's 12, and there's also a rule 0 of where it's like setting the standard. Like, is this a relational model that you should be creating? Along with that, there's 3 objectives that relational models go behind. There's data independency, commutability, and set processing. And also along with those, there are 3 concepts that relational models like to follow, which are data structures, data integrity, and operations. And under the operations, we go into like what is relational algebra. So relational algebra is a pretty common query language that's used. As you all know, some of the query language that we use already from previous chapters we discussed in class. For like management operation side, it's pretty much taking 2 inputs or even more and combine them to 1 output on a table. So as you can see, there's on the next slide that we're going to go to soon, there's going to be an example showing that. Here's one example of one of the relational algebras, which is union, which it takes the table A, which has 3 rows and 3 columns, and table B, which also has 3 rows and 3 columns. But as you can see, there's 2 rows, one on each table that has the same indexes, so like x2, y2, z2. And when you union them together, if you can see way over there in the far bottom left corner or right, depending on the table comes down to 1 input, but instead of duplicating x2, y2, and z2, it only shows 1 because it doesn't take the duplicate of it. So it just removes 1 and just keeps that 1 and just combines it all to the 1 table. So today we're going to talk about our case company for our presentation, which is Wayfair. But before we get into that, let's talk a little bit, and let me ask you this question. What do you think about when you hear the company name Wayfair?
So Wayfair is a furniture and appliance e-commerce website. They do all of their sales online. And so basically what we're going to be talking today with that is a particular instance with how they built their databases. So we move forward. This is we're going to talk about a particular instance in a way that they've done used a relational database through SQL. They made around $9 billion in 2019 online solely. They are completely open sourced, which is very helpful when it comes to making this project. But so specifically, we're going to be talking about how they've organized their consumer information into a relational database, or as close as they can get. This is just a chart of their revenue. It shows 2019. This is net income. This is not after they've deducted anything. So take that in mind. But so on the next, this is going to be a combination of things. But so basically, in 2017, Wayfair decided that they were going to expand their server stacks, and they needed to come up with a way to load balance that as best as they possibly could. This is all solely for their consumer information. So how they've where they store all of their the consumer ID, their wish list, what they've bought, where they're shipping it, all that stuff. So this is a graph of what they had initially. They call their instances on the servers for the consumer information shards, just to explain that to everyone. These are in different locations, some in the US, a couple in different countries. I'm not going to go into that because irrelevant information. But this is the load on each of those servers for where the information is stored. So for instance, if we had someone in the EU create an account with Wayfair, that information would be stored on a server in the table for consumer information for the EU server. When they expanded their storage, they made more servers in different locations, but they discovered that the information was being kept on one server, but not being able to be accessed by the others without causing a severe load on the whole system. So to fix that, they created a schema for all of the tables overarching, and when they created a set of code that would run it at the start and find the information throughout all of the tables across the world. And that made it so that the servers were a lot more load balanced and they didn't have to move any information from one server to another. We're going to move into our discussion now. So if you want to start with question one.
All right, guys. So the first question we have for you all: how are relational models superior to other methods of organizing databases? And like an example, like some databases prior to like 1970 or so.
Okay.
I'll take a crack at it. So, we have relational databases, very easy to understand, very easy to implement. When we're talking about the small to mid-sized scale, it makes the most sense from a financial perspective. I'm not going to say 100% of the time because that's not going to be true. But certainly for the bulk of cases, when you're talking about having fewer than, I would probably say, 10 gigabytes worth of data, so probably a couple million records, you're going to come out ahead to use a relational model. It's going to be very easy to understand. When you talk about the models that existed prior to relational databases, very difficult to understand, even for database administrators. I mean, when you look at the amount of knowledge that's required to understand a database that is not using a relational model, it's a lot. It's basically, instead of having one class where you learn the relational model pretty well at the end of the semester, it's like you have one major. So you go back prior to 1970, even into the 80s, there was database administrative majors. A lot of research universities had those. So it's not just like something you went to a two-year degree for. I mean, it's certainly substantial commitment to understand and to be able to use that for a business perspective. Beyond that, I think that relational models integrate very well, particularly SQL, with many other applications. If you have a Python application, it integrates amazingly well. If you have other sorts of applications, it integrates very well. Just a lot of other advantages like that. I'm sure I could list off 20 more, but I don't want to hear me talk all day. So
think the most important thing, I think you briefly touched on it, would be usability for people who aren't necessarily programmers, so they can make queries and access the information and just use it like in human resources or something like that. So, question two. So, question two is, why are COD's rules/commandments so important? What are they? What are their purposes, etc.?
Follow those rules and commandments, because if you don't have to follow those rules, it's not really going to work like you intended to work.
Right, because that's one of the things for sure with like relational databases and things, like having those cloud commands to follow by helps kind of define like, is it actually a relational database, or is it just like a normal like database system that you're trying to use? And also like how you said, just following those guidelines is the key to it, because if it doesn't follow it, it's pretty much like there is no relational database.
I'd like to jump in and add. I think Damien had a great answer, but I would just add that, in addition, it provides you a lot of advantages to follow COD's kind of suggestions for making a good database, because it's going to reduce redundancy. Redundancy is one of the most important things that you want to reduce as a database administrator in most cases, because the more redundancy you have, the more processing it takes to do things, the more data that you have to have maintained. And when we talk about maintaining data, you say, why is that an important thing? Well, for one thing, it's very costly. You're not just buying one hard drive and sticking it on if you're a multinational. You're buying 3 or 4 for every amount of data. You have to have it redundant. You have to have it, in sites that aren't in the same place. Otherwise, what could happen if a natural disaster happens? Let's say Hurricane Katrina rolls through. We're headquartered in LA, or not LA, but
Louisiana.
Louisiana.
New Orleans.
Yeah, New Orleans in particular. That'd be very unfortunate if we only have one copy of our information. So we want to have this redundant. So we're not just going to put it in one place, in one geographical. We're going to separate this out geographically. Now, if we're doing cloud storage, we still need to have that consideration. We need to make sure that the provider has our data, not just in 1 or 2 geographical. We probably want to have it in 3 or 4. Now, for something very important as a database. Now, there's other types of information. We probably wouldn't need to have it in 3 or 4. Maybe just 2 locations is fine. But just having the ability to reduce the storage by following the principles, that's very important.
So why do you need to specify a unique identifier for each row of data? This goes back to primary keys. So a unique identifier, from what we understand, is if you don't have a unique identifier in each row of data, you can run into issues where it might not work entirely. It might just error out and crash. Or you'll have issues where you'll get the wrong row of data that you wanted, or it'll get duplicate rows or issues like that. So it's very important to make sure that you specify unique row or data in the tables. So this goes also back to data integrity. That's one of the things that we're talking about in this instance. Anyone else want to pitch in? Anyone on Teams? Come on.
Well, I'll jump in. Just kind of adding to your answer. It's very helpful sometimes to be able to, for example, if you're trying to find a specific student, you type in their student ID, boom, you pull them up. That's pretty helpful. And then I had to search through first. It saves time. You mentioned some problems that you run into, particularly when you're dealing with more complex relationships. Having a unique primary key, for one thing, is required inside the table. You cannot have a non-unique primary key. You also have to specify a primary key, or at least you should. But certainly the different languages kind of handle it slightly different implementation. But the main advantage is you have one single thing that you can say, this attribute or attributes, if it's a composite key, uniquely identified, and if I can find out what that is, I can return the information that I need for that particular instance. So I think from that perspective, it's certainly very important.
For sure.
Anyone else? All right, moving on to our last question.
My favorite question.
Yeah.
So last question. So here's your last chance to get bonus points. here.
Hopefully some of you guys recognize this question.
What is the purpose of intersect operators and how do you simulate it in MySQL?
This is Jonathan Bishop, by the way. Doing the intersect is like combining two different statements into one. Like you want to do two statements and make it into one statement, basically. And instead of the intersect, isn't it the join in MySQL?
Close. But so this was the reason why I brought this up was because it was on the test and I got it wrong. So the intersect command will take the rows that are the same on both tables. So it's the center of the Venn diagram as he described it during the lecture the other day. And how to simulate it in MySQL is you use and exist. So the join command joins two tables together completely. The intersect command takes only the entries that are the same. Anyone?
Just to kind of add to that, when you say entries that are the same, you're talking about the join condition.
Yes.
The same for both,
Yes.
just to make sure
Yeah.
everyone's clear on that. The other attributes can be different.
Mhm. Anyone else want to take a crack at it? Bonus points? The last question for our presentation? Anyone? Going once? Twice? 3 times? All right. Thank you guys. I hope you have a good day. Have a good weekend. Yeah.
All right, thanks, guys. Don't forget to grab the pen. All right, so now we've got a second presentation from Beckett and Rena. So if one of you will go ahead and share your screen, we'll just go ahead and get started from there.
All right. Can you hear me?
Yeah, we can hear you.
All right. I'm gonna go ahead and share my screen.
Sounds good. And just a reminder to everyone joining us via Teams, certainly when they get to the discussion, I do encourage that you participate.
Oh, wait, I think I have to stay at a full screen, right?
Either way is fine. We can see it fine in full screen.
All right. All right. Raina, are you here?
Yeah, I'm here.
All right. What's up? How's everyone doing, guys? I'm Beckett Haupt,
And I'm Raina Duncan.
and we are presenting Chapter 9 also, the relational model and relational algebra. So just kind of an overview. We're gonna go over the introduction of what it means and advantages, major concepts of it, present our case, and then our discussion. Here's just kind of a picture example. So the relational model, just a few basic elements of it. It was majorly developed by Edgar F. Codd, and he was a computer scientist. And the main purpose of a relational model is to implement design to overcome flaws in the traditional modeling techniques, and basically, it needed modeling was very outdated, and this relational model creates simpler entity interaction for users and programmers and things like that. And it was first brought to life by Codd in 1969, and also helped me replace procedural command, which was difficult. So some advantages of relational modeling. So first off, you have a greater data independence. And what that means is your models are going to be separate, your, say, physical and logical models. And data independence also means that you want your data to be transportable and not tied down to a single system. So you need to be able to access information from anywhere, and relational modeling helps bring that independence to the table. It also brings communicability, which helps it, modeling become easily understood by programmers and users, and along with understanding things like ERDs and conveying the components of the data model. And as well as set processing, which can help increase productivity for a programmer. And the more advanced modeling is easier to use than old techniques. So there goes data independence. I already went over that. So there are those main points from those. All right, and some major concepts regarding to relational modeling. These include data structure, integrity rules, and operators. So data structure, the main point is it's very important to understand what our data actually means. And data structures consist of things called domains, and these contain values with all the same data type, which is helpful for organization. And only attributes from the same domain should be compared in these. And the data structure also structured with keys, like we're familiar with primary keys, candidate keys, alternate, foreign, and all that. And primary keys, are the unique identifier of a certain row. A candidate key can be a primary key with those attributes. And foreign key, it an attribute, and it has relations that is related to the primary key of a relation. Sorry, that was confusing. Our next major concept are integrity rules. And these are basic rules for a logical workflow. And these consist of entity integrity. And so that would be an example of each row in a relation needs to be unique. You can't have redundant data. And say components of the primary key, they can't be null, and just typical errors like that the integrity rules, you have to follow these integrity rules. And referential integrity consists of, the database can't contain foreign keys that aren't matching values, and foreign keys have to have a corresponding primary key. And so these rules kind of, keep you in check. And another major concept for these are operations. And this deals with the relational algebra. And there can consist of 8 operators to manipulate relationships of the data. And these are very vital with MySQL. The 8 operators are the restrict, project, product, union, intersect, difference, join, and divide. But they're a primary set. Only 5 are required: or restrict, project, product, union, and difference, I believe. And so these operators, each one serves a different purpose of how they extract information from a row or a column, things like that. So like for one of the required ones, a restrict operator extracts rows from a single relation. And then like they were talking about with the intersect on the previous presentation, it's kind of like the Venn diagram, and these create relations with rows appearing in 2 different areas. So, all right, and now for our case example, we decided to go with IBM and its connection with relational models. And so me and Raina are going to discuss this, but just the main point is that relational model implementation with IBM was they created a database called DB2 in the 1980s, and it was a product designed to interact with data very efficiently. And DB2 just in general helped the company access all kinds of data with over several different operating systems. And this was when it came out in the 80s, and this was very monumental for this company. And yeah, so here we have Raina, and if you have information on this.
Yeah, so we decided to use IBM and specifically for the relational model with the DB2. So it was originally designed by IBM in the 80s for their specific platform. However, in the 1990s, the company decided to make it compatible with other operating systems such as Linux, Unix, and Windows. The features of the DB2 include availability and data access, massive scalability, deployment flexibility, and lower cost of ownership. Apart from that, it's suitable for large organizations which have diverse and high volumes of data.
So here's this is from the IBM website. This is showing the additions of the database, and the DB2 database is one you can purchase it for you know, your company, things like that, and has different levels of what you might need.
So
You
to
know,
kind of expand on that a little bit, it kind of goes with our first question, which was about the financial pros and cons of DB2. With this picture, it shows that you can get the community edition for free. For $79.17 per month, you can get the basic package subscription, or you can do the full price for $1,900. It was a little bit annoying trying to find out the correct information for how expensive it would be, since you would have to put in like a contact us, like you would have to request additional information for it for your company.
and overall financially, this helped out IBM tremendously. And prior to its release in '98, IBM wasn't as major. And over the years, you know, with their stock growth and things like that, these kind of platforms that they released are pretty monumental. And the just like a fun little fact, DB2 it was written in a few languages like C, Java, C++, which hopefully we'll get into next year or something. Yeah, DB2, it's a relational database. That's what the whole point of it is. And it could be hosted, you know, from a traditional server in say a warehouse or a cloud server. So yeah, that is our case example with IBM. And then here are our discussions. We're going to be going over pros and cons of relational modeling based off the 3 factors. So first question, what do you guys think are some pros and cons of relational modeling from a technological perspective?
And let me just remind everyone, if you're joining us via Teams, we certainly do want you to get extra credit. So it's 8 points if you unmute yourself and answer one of these questions.
Okay, so some of the technological pros, we are doing it about relational modeling, but specifically for the DB2 is that it's a fast, sturdy platform to use that is specific to Linux, Unix, and Windows, so it can be customized. It has a robust database performance in the SQL schema, and it's easy to use with SQL programming. You can host the relational databases in the cloud, on local servers, on desktop machines, on private clouds, or even ITO devices, as long as you're complying with the license. Some of the cons, especially for DB2, is that support is kind of hard to come by unless you pay for the IBM support, even if you pay for the IBM support, it can take a lot of hours for them to be able to help you with that. The issue resolution and the debugging is difficult, and most of the time, third parties are going to be needed.
Anyone else have any input on the technological perspective?
Yeah, I'll jump in here. So, we're talking about technological perspective. It's important to remember, we're talking about what does a relational model provide us that other models don't. Probably one of the biggest ones being, the elimination of redundant information. I've said that throughout the whole semester, but it's probably the most important concept of relational modeling. If you have a procedural model, or if you have a non-relational model, some of the more modern things like MongoDB, some of the others that are becoming increasingly popular, they're great for certain things. Certainly for processing, they can be more efficient. Maybe not procedural depending on what you're doing, but certainly a non-relational model, if you have tremendous amounts of data, yeah, it'll process it faster. But you do lose the ability to not have redundant information. Not to say that you will have, full redundancy, but you'll certainly have some repeated information that you wouldn't have to have with a relational model. So if you're a very large firm, that may be worth it to you because the extra processing, being able to get data out faster could certainly be worth it. Companies like Uber, very famous example of using a non-relational data model because they have, millions of rides each day, people using their service. They want to be able to provide a price very quickly. They don't want to have to wait around, and spending a little bit more on storage is certainly worth it to them. So, from that perspective, it can be an advantage and a disadvantage.
Exactly. All right, and we also have what would you guys think are some pros and cons from a financial perspective for this relational modeling?
This is Colby Stroop, but like I said earlier, you gotta pay directly for it. I feel like that'd be a con, or pay for like support from like IBM or something if you're using that example.
Right.
So I feel like that could kind of get a little bit pricey, I'd imagine.
Yeah, the packages for this DB2 database definitely can get pricey and really are meant for, major companies.
Exactly. With
Yeah.
like DB2, they don't provide any commercial support out of the box, so then you'll end up having to pay for something later.
And from I guess IBM's perspective, or a company purchasing this from IBM, it can get pricey with licensing and if you have say disaster recovery set up, things like that. And yeah. So anyone have any pros financially?
Well, I mean, if this helps you, this is David Banks, by the way. If relational modeling helps you save time overall, I mean, as everybody knows, time is money. So, I mean, I think that could be a big benefit, if it helps streamline the process or anything, that helps you save money overall, even if there is a financial pill up front.
Definitely. And another point is a lot of open source databases have no costs to set up, and with that comes very little support, and so part of the price you're paying is that support from IBM and a professional database, basically, which is definitely a pro.
Yeah, let me just jump in. You're talking about support contracts. It's very common, even for open source applications that have a free version, to have some sort of support agreement. And if you're a company that's relying upon it to store your entire data, it certainly makes sense, I would say the vast majority, if not every single time, to purchase that support contract. If you cannot purchase a support contract, you have pretty substantial problems, quite frankly, if you're a company. And there's not really going to be a great way around that. Because something happens with the database, maybe an update doesn't work well with your system, it's good to have someone who's very familiar with the database that you're using. They're familiar with coding it and all, to go through and help you resolve that issue. Now, otherwise, you're relying on things like forums. You may get a response, you may not. The person may know what you're talking about, they may not. So I think that if you're a company, it doesn't matter which product you're using. If it's a product that you're relying upon for your revenue, or if you're relying upon it for maintaining your customers, it certainly makes sense to purchase a support contract. I would never recommend against that. But then, kind of beyond that, we're talking about, pros. The biggest pro is this can make your firm more efficient. So if you're able to reduce the cost of goods sold that you're having for your firm through things like reducing, the average or the amount you're spending on information technology, let's face it. We think back to Porter's value chain. Is it a primary activity or is it a support activity? For most firms, it's going to be a support activity. What do we want to do with support activity? We want to reduce the cost of them. So certainly from that perspective, if you're a small, mid-sized firm, or even a large firm that doesn't have, tremendous amounts of data, certainly it's going to make sense from a financial perspective. So that's kind of what I would say to that.
Definitely. All right. Anyone else? All right. And then for our last question, we're asking what are some pros and cons of relational modeling from a social perspective, which is kind of difficult to tie in, but if anyone has any ideas. All right. Well, some pros that we came up with from us for socially, this kind of goes on to the people who actually would, use them daily or work on them. And so before these relational databases, really only the people who had the advanced programming skills, could retrieve or work on that data and provide it for you. And one of the major pros of DB2 is it makes it a lot easier for a standard or a normal guy to use this information. And so for it's more on a user end. Socially, a major pro is the usability of DB2. Miranda, do you have any points on any pro points?
So we've been talking about DB2, but also another kind of relational model would be the SQL. So SQL lets you join tables so that you can understand the relationships between the data or how the tables connect. SQL allows the ability for you to count, add, group, and combine queries. It performs the basic math and subtotal functions. So it's going to help you with that. It helps the analyst so that they can order the results by the date, name, or really any column. And that feature helps make the relational approach the single most popular query tool in business today. So it's definitely going to help not only just analysts or people, who are within companies, but just a normal person who wants to just kind of make a relational example per se. If they have something that they want to group together, it's going to make it easier for them.
All right, does anyone else want to jump in here? Just as a reminder, 8 points on exam 3. All right, and if no one else wants to jump in, I'll go ahead and attack this. So when we talk about a social perspective, we're talking about, people. We're talking about, socially, we're probably talking about not just one person, but society. And we think about what does relational data models enable society to do? There's a big debate about the ethics of data collection. And that can be a major pro to be able to better understand your customers, to be able to increase revenue, by targeting people who are more likely to purchase something based upon information we can gather. It can also be a con. Many people would be hesitant to be put in the database, so to speak. I think that there's going to be some privacy concerns with stuff like this. I'm not here to say whether those concerns are justified, whether they're not justified. That's really for you to determine for yourself. But certainly, I think many people would say there are certainly some privacy concerns that are enabled through these large databases and through having that information collected. So socially, I think that's a very large concept. And then, of course, this does feed into financially. So if we're a firm, we have a website, we can collect information about our users. What can we do with that information? So our information, we can sell it. So that could certainly be a big boost to us. Now, the downside is, what about our goodwill? What about our reputation, intangible assets? If it comes out that a firm is selling your information, that could certainly harm their goodwill. And if we reduce goodwill, it means we're reducing the value of our firm. So I'm not here to say this is the right answer, this is the wrong answer when we're talking about this kind of somewhat, what's a good word here? A somewhat controversial topic. I would never say this is what you should believe, this is what you should, or anything like that. But certainly, it makes a difference. Financially, this is a very good question. I think, looking at this, is it advantageous to do? I don't believe you could answer that with a yes, no. Well, I mean, you could, but, to fully explore this, I think it'd really be an interesting thing to do. So anyone else want to add anything?
If no one else has another con socially related to the people who actually use it, or a programmer, or someone not being a programmer, would be the con, as if you don't know the basic information about this or SQL language, really this is not going to be a database that you're going to want to use. And that just it's not necessarily as easy to use as other technology online, which is definitely oriented for the average consumer.
All right, guys. Well, thanks for presenting today. We certainly do appreciate it. Make sure that everyone submits their homework. I don't remember when the due date is. I think it might be this Sunday. It might be next Sunday. I think it's probably this Sunday. Anyone know off the top of their head? I should.
November the 1st on Cengage.
You talking about inside of Canvas?
Yes,
Gotcha.
Canvas, my bad.
Gotcha. Yeah, so I think it might be 2 weeks from then. But certainly do make sure that you take a look at it. I think it's just one question. I don't remember exactly what the question is, so I don't want to tell you the wrong question. But it's certainly there. I'd encourage everyone to go ahead and get started on that. Don't want you to spend too much time, but certainly think about it. Provide a thoughtful answer. I certainly look forward to reading those. Apart from that, if there's no other questions, certainly go have a good weekend. But I will stick around in case anyone has any questions.
All right. Thank you. Thank you, guys.